Have you ever wondered how the vast oceans that cover our planet came to be? These seemingly endless bodies of water that shape our world, our climate, and our very existence are a captivating enigma, a puzzle that scientists and researchers are still piecing together. The oceans are more than just expanses of salt water. They are the cradle of life, the engine of our weather systems, and the ultimate source of the water we drink and the air we breathe. Over 70% of our planet's surface is covered by oceans, yet their origin remains shrouded in mystery, a tale untold. The formation of our oceans is a story intricately woven into the fabric of our planet's history, a complex narrative of geological processes, cosmic events, and chemical interactions. It's a tale that takes us back billions of years to the very dawn of our planet and even beyond, into the vast reaches of the cosmos. There are many theories about how water, the lifeblood of our oceans, came to be on Earth. Some suggest that it was here from the very beginning, trapped in the rocks that formed our planet. Others propose that it was brought here by comets or asteroids, icy heralds from the farthest reaches of our solar system. Yet others posit that it was produced right here on Earth, through complex chemical reactions deep within our planet's mantle. Each theory has its merits and its challenges, and each adds a unique piece to the puzzle. This is a mystery that we are only just beginning to unravel, a question that has captivated scientists for generations. As we delve into the enigma of ocean formation, we'll explore these theories and the evidence that supports them. We'll journey back in time, to the early days of our planet, and out into the cosmos, in search of the origins of our oceans. To understand the formation of our oceans, we must journey back in time to the early Earth. Picture this: 4.6 billion years ago, the early Earth, a molten volcanic landscape devoid of life. The Earth as we know it today was a far cry from this fiery, inhospitable world. It was a realm of extremes, with temperatures soaring high enough to melt rock and form vast seas of molten lava. In this tumultuous world, water, as we know it, was a scarce commodity. With temperatures so high, any water that might have existed would have evaporated instantly. But beneath the surface, a profound transformation was taking place. Deep within the Earth's crust, volcanic activity was incessantly churning. These volcanoes, like colossal chimneys, allowed the Earth's interior to exhale, releasing an array of gases into the atmosphere. This process, known as volcanic outgassing, was a key player in the story of our ocean's creation. Now you might be wondering, what does volcanic outgassing have to do with water? Well, one of the gases released during this process was none other than water vapor. Yes, the same stuff that fogs up your mirror after a hot shower. This water vapor, along with other gases, formed the Earth's earliest atmosphere. But here's where things get interesting. As the Earth cooled over millions of years, the water vapor in the atmosphere began to condense. Imagine the steam from your hot shower cooling and forming droplets on the mirror. That's essentially what happened on a global scale. Yet, it wasn't as simple as steam condensing into droplets. This was a process that took millions of years, and it was only the beginning of an incredible journey. This water vapor was setting the stage for the next act in the formation of our oceans. So we've traced the water's journey from the fiery depths of the Earth's interior, through volcanic outgassing, and into the atmosphere. But how did this water vapor transform into the vast oceans we know today? Imagine an era of endless rain lasting millions of years that filled the basins of the Earth. This was the reality during a period of our planet's history known as the Great Rainfall. As the Earth cooled down after its fiery birth, a dramatic change was set in motion. The Earth had been a molten sphere, too hot for liquid water to exist, but as it cooled, water vapor, previously held captive in the atmosphere, began to condensify. This was the start of the Great Rainfall. Millions upon millions of years passed, and the rain kept falling. Over this unimaginable span of time, the Earth gradually transformed. It was akin to the slow turning of a potter's wheel, shaping and reshaping the land. Now you might be wondering, how did this continuous rainfall form the early oceans? Well, our planet's surface isn't perfectly smooth. It's more like a crumpled piece of paper with peaks and valleys. These depressions, these valleys, they acted like nature's own water reservoirs. As the rain kept falling, the depressions began to fill with water, slowly at first, then faster and faster. The water levels rose, flooding over the rims of the deepest depressions, creating the earliest seas. These bodies of water were the precursors to our modern oceans. They were smaller, shallower, but they were there. The Earth, once a red-hot ball of molten rock, now had water. It had oceans. But here's the catch. The water from the Great Rainfall only accounts for a portion of the water in our current oceans. The rest? Well, that's a story that takes us beyond Earth, into the farthest reaches of the cosmos. So the next time you stand by the ocean, think about this. Each wave that crashes onto the shore is a testament to millions of years of rain, falling drop by drop, filling up the basins of the Earth. Yet this only accounts for a portion of our oceans. Where did the rest of the water come from? Believe it or not, a significant portion of our oceans might have come from outer space. Yes, you heard it right. The cosmic neighborhood has been instrumental in shaping our blue planet's water bodies. Let's take a trip back in time to the early stages of our solar system. Among the swirling chaos of dust and gas, comets and asteroids were born. These celestial bodies, like cosmic ice cubes, were rich with frozen water and other volatile compounds. As they whizzed around the solar system, some of them inevitably found their way to our still-forming Earth. Imagine these icy travelers, hurtling through space at astronomical speeds, colliding with the young, fiery Earth. The energy of these impacts was so intense that it could vaporize the ice, releasing water into the atmosphere. Over time, the relentless bombardment of these celestial bodies could have delivered a considerable amount of water to our planet. But how can we be sure of this? Well, scientists have found compelling evidence in the form of deuterium. Deuterium is a variant of hydrogen that carries an extra neutron, often found in the water of comets. Interestingly, the proportion of deuterium in Earth's oceans closely matches that found in comets, strongly suggesting a cosmic origin for some of our water. This theory goes hand in hand with the idea of Earth's water originating from within. It's likely that both processes played their parts, with water from the planet's interior spewing out through volcanic activity, and cosmic water being delivered by comets and asteroids. But it's not just about the amount of water. The arrival of these icy celestial bodies could have also brought other essential elements for life, such as carbon, nitrogen, and phosphorus. In essence, these interstellar ice cubes may have not only filled our oceans, but also kick-started the chemistry of life. The formation of our oceans is a complex process that took billions of years and involved numerous factors. So next time you take a sip of water, remember you might just be tasting a drop of the cosmos. The oceans are not just vast bodies of water, they are crucial to life as we know it. They are the lifeblood of our planet, pulsing with a diversity of life that is staggering in its complexity and beauty. From the tiniest plankton to the largest whales, the oceans teem with life, forming an intricate web where every creature plays a part. But the oceans do more than just harbor life. They play a pivotal role in regulating our planet's climate. Acting as immense heat sinks, they absorb and distribute the sun's warmth, moderating temperatures and shaping weather patterns. They are the great thermostats of our planet, maintaining a delicate balance that allows life to flourish. Beyond supporting life and regulating climate, the oceans have also shaped human civilization in profound ways. They have served as highways for exploration, trade routes for commerce, and sources of food and resources. Our societies, cultures, and economies have been shaped by our relationship with the oceans. Yet, as we've explored in our journey through the formation of oceans, these vast bodies of water didn't appear overnight. They are the product of complex processes that began with volcanic outgassing on the early Earth, followed by the Great Rainfall, and possibly supplemented by cosmic water delivery. Understanding this formation process deepens our appreciation of the oceans and underscores their value. But this appreciation must translate into action. Our oceans are under threat, facing challenges from pollution, overfishing, and climate change. As we've seen, the oceans are not just bodies of water, they are integral to life on Earth. Their health is our health, their future is our future. So let's cherish our oceans. Let's celebrate their beauty, marvel at their complexity, and work to protect them. For in doing so, we're not just preserving bodies of water, we're safeguarding the legacy of billions of years of planetary history. The story of our oceans is a testament to the incredible dynamism and resilience of our planet.